Now the next application is the dynamic lift of an aeroplane. The aeroplane dynamic lift means what? When the aeroplane is lifting up, it is taking off. At the time, definitely its machinery parts are helping it, but the atmospheric conditions also help it, also support it in the lifting, and that can be very easily understood. That can be very easily understood with the help of this dynamic lift of an aeroplane. With the help of the dynamic lift of an aeroplane, we can discuss it. How to discuss it with the dynamic lift of an aeroplane? Look, this is the wing, this is the shape of the wing of an aeroplane. It is the shape of the wing of an aeroplane, and you can very easily understand what is the shape of this wing. Its wing is plane in the lower side and convex in the upper side. Curved. Convex on the upper side, and it is like this. It's shaped like this. It is called streamline. It is always, the shape is made in this way. What will happen when the aeroplane is lifting up? The air layer, these arrows are indicating the directions of the air layer. Air layer will be moving as shown in the figure. Obviously, air layer will have some velocity, but before I come to this point here, I discuss one thing. Bernoulli's theorem says P by rho plus half V square plus GH is a constant. But if I consider Bernoulli's theorem for the 2 points which are at the same height, okay, if that means for H to be constant, what we can say in that case? P by rho plus half V square should be a constant. Look, it's a very important thing. You can see it is a special case of Bernoulli's theorem. It's a special case of Bernoulli's theorem. What happens? In Bernoulli's theorem, P by rho plus half V square plus GH is equal to constant. If I am using this Bernoulli's theorem for the 2 points almost at the same height, means H will be a constant. In that case, GH will become a constant. So what we shall have? P by rho plus half V square will be a constant. Look at this. P by rho plus half V square should be a constant. Okay? This we are getting in this case. What does it indicate? It indicates if at a point here the speed will be more, velocity will be more, pressure will be less, and vice versa. Speed will be or velocity will be more, the pressure will be less, and vice versa. Keeping in mind this thing, we are considering here upper surface and lower surface. At these 2 points I am going to use Bernoulli's theorem. They are almost at the same height. Then what will happen? Here, look at this. Here, air layer will be covering larger distance. In the lower portion, air layer will be covering smaller distance as compared to the upper one. So, velocity, here the velocity will be less. And here, velocity will be more, because in the same time air layer is moving from this end to this end. Then what will happen? Speed of the air layer or velocity of the air layer will be more at the upper end than the lower end. And according to Bernoulli's theorem here, if velocity here will be more, that is the pressure should be less, and here the pressure should be more. Here the more pressure, here the less pressure. So what will happen? It will always be shifted, it will always be pushed from the greater pressure side to the lower pressure side. It will be pushed from the greater pressure side to the lower pressure side. कोई भी फ्लूइड का जो मूवमेंट होता है या लिक्विड का जो मूवमेंट होता है वो हरदम ग्रेटर प्रेशर साइड से लेस प्रेशर साइड की ओर होता है। तो यहां पर भी ग्रेटर प्रेशर टू लेस प्रेशर, एंड दिस इज हाउ इट इज हेल्पिंग, दिस इज कॉल्ड डायनामिक लिफ्ट, इट इज हेल्पिंग इन द लिफ्टिंग ऑफ द एरोप्लेन। द weather condition, the climatic condition is helping it. But how it is helping? With the help of the Bernoulli's theorem, it is discussed. Right? A question is there in NCERT. I just want to discuss it with this here. It is question number NCERT. Okay. Question number 10.14. Please see to this question. 10.14. In a test experiment on a model aeroplane in a wind tunnel, the flow speeds on the upper surface of the wing and lower surface of the wing are 70 meter per second and 25 meter per second respectively. Very simple. It is saying, suppose I am repeating this figure. Here, upper surface, it has the upper wing 70 meter per second. Here 70 meter per second, and here 63 meter per second. Okay, the velocities or the speeds. Okay, what is the lift on the wing? What is the lift on the wing? Okay, if its area is 2.5 meter per second square, area of the wing is how much? It is 2.5 meter square. और क्या दिया हुआ है? Density of air, rho of air is how much? 1.3 kg per meter cube. Look, these things are given. Okay, fine. How? लिफ्ट का मतलब क्या हुआ? व्हाट आई हैव टू फाइंड आउट? द फोर्स. किस फोर्स से वो ऊपर की ओर जाएगा? ठीक है, कोई प्रॉब्लम नहीं है. आई एम डूइंग हियर इन दिस वे. आई एम टेकिंग द हेल्प ऑफ दिस फॉर्मूला. P1 by rho plus half V1 square is equal to P2 by rho plus half V2 square with the help of this formula. Okay, P1 V1 is here, P2 and V2 are here. ठीक है? So what we shall take here in this, we shall take this is P1 by rho plus half 70 square is equal to P2 by rho, not given, plus half 63 whole square. Okay, then प्रेशर कहाँ है ज़्यादा? नीचे. So P2 minus P1 by rho is equal to half here 70 square minus 63 square. Look, P2 minus P1. So what is P2 minus P1? P2 minus P1 is equal to half. Rho is 1.3 into 70 plus 63 into 70 minus 63. And what you have to find out? The net, what will be the, what is the lift on the wing? Okay, lift on the wing, that is the force. F equal to P2 minus P1 into A. And very simple, half 1.3, here it is 133 into 7 into 2.5, this much Newton. Please work it out and check your answer. I think you can do it very easily. You just do it and check your answer. You can check your answer with the help of this. Okay? Some other applications are also there. I can consider one more, which is a very common, you can say, it's a very common application. This application is very important, dynamic lift of an aeroplane. With that, I am attaching one more application. It is generally in the stormy weather, the roof of the house is blown off. In a stormy weather, the roof of the house is blown off. Why it is so? It's a very common feature. The roof of the house is blown off. How it is blown off? What happens? Suppose in a stormy weather, here the air has the velocity of the air is greater. Obviously, inside the hut, suppose it's a hut, inside the hut the air is calm and quiet, so V is less. So according to this Bernoulli's theorem application, here the pressure will be less. Velocity is greater, pressure is less. Here the pressure is more inside में pressure क्या होगा? More होगा. So what will happen? It will be moved from greater pressure side to the less pressure side. That's why it is blown off. Very simple, with the help of the Bernoulli's theorem. Okay, this is about the dynamic lift of an aeroplane, and it's a very simple, small application. Okay, we shall discuss some more things in the next lecture.